Welcome to This Explainer. Today, we're diving straight into what I like to call the API multiverse. In modern system design, APIs are literally the invisible engines running our entire digital world. Whether you're booking a ride, endlessly scrolling social media, or streaming your favorite show, there are these incredibly complex back-end systems constantly talking to each other. But how they communicate? Well, that's evolved dramatically. Today, we're decoding the exact communication protocols that make all this massive digital coordination possible. Because as we'll see, these aren't just technical tools, they are the distinct languages of digital communication.
So think about it for a second. If your microservices had to actually talk, how would they do it? Would they send a standard piece of mail and just kind of wait days for a reply? Would they jump on a direct, urgent phone call? Or would they just broadcast a message out on the radio to anyone who happens to be tuned in? This isn't just a fun little analogy. It's the fundamental architectural challenge we face today. Because as our apps scale up from simple monoliths to these highly distributed microservices, using the wrong communication method can literally turn a tiny bottleneck into a complete system meltdown.
Just to set our baseline before we look at the actual tools, what exactly are we talking about here? Simply put, a communication protocol is a set of rules defining the syntax, semantics, and synchronization of data exchange between devices. It's the agreed-upon contract. It's what allows different application layer software, which might be written in completely different languages like Go, Python, or Java, to interact seamlessly without getting entirely lost in translation.
Section 1. Synchronous Delivery. The Old Kingdom and the Query Mage.
Okay, starting in the realm of synchronous delivery, where a system asks for something and stands by waiting for a direct response, we have our first big showdown, REST versus GraphQL. Think of REST as the standard postal service of the internet. It uses standard HTTP, exchanges data in plain JSON, and everyone supports it. It's awesome for public APIs, but because it usually returns fixed payloads, it's super prone to overfetching, sending you a massive box of data when you really just wanted one piece of paper, or underfetching, where you have to make like 5 trips to the post office. Then we have GraphQL, which is honestly more like a query mage. Instead of just taking a fixed package, the client dictates the exact shape of the data at once. You get precisely what you asked for in one single request. For mobile apps with tight bandwidth, that is an absolute game changer.
Section 2. High-speed delivery with gRPC.
But what happens when we move away from public-facing apps and dive deep into the internal backend? Listen to this quote. gRPC is the FedEx of microservices, unbeatable for urgent, high-volume deliveries. When you have internal services that need to talk rapidly, like a payment service communicating with inventory, the standard REST postal service just won't cut it. It's too slow. You need an express courier. And that's exactly where gRPC, originally developed at Google, comes in to handle your most urgent, high-throughput system communications. So how does it actually pull off that kind of speed? Well, it completely ditches human-readable JSON text. Instead, it uses protocol buffers, which is a super compact binary format. It's literally the difference between sending a huge, rambling letter versus a dense, coded telegram. A payload that's 100 bytes in JSON might only be 20 bytes in protobuf. Plus, it runs over HTTP/2, which means it can multiplex, sending multiple streams of data all at once over a single connection. Add in automatic code generation and strict type safety checks, and you've got a protocol running 5 to 10 times faster than REST for internal operations.
Section 3. Handling the room creation storm.
Let's look at a high-stakes scenario to see this in action. Imagine a massive traffic spike, 1,000 users trying to create chat rooms at the exact same millisecond. If you're using REST, your system frantically tries to open 1,000 separate TCP connections and push huge JSON payloads. The system chokes, latency goes through the roof, and you get timeouts. Now, WebSockets? Fast, because it's one connection. But if the server actually crashes under the load, putting the state of those 1,000 requests back together is a total nightmare. But look at gRPC. It handles 1,000 tiny binary frames over one multiplexed connection. Parsing is lightning fast. And if the system does get overloaded, it uses a feature called deadline propagation to instantly kill stale requests so the system can recover immediately. For architects, this is the difference between your system completely failing during a viral moment or gracefully surviving so you don't get paged at 3 a.m.
Section 4. Real-time whispers with WebSockets.
But hold on. What if you're building a live multiplayer game or a real-time chat app? We can't really use gRPC easily in the browser for that. Enter WebSockets, the real-time whisperer. With standard HTTP, the client constantly has to ask, "Hey, got new data yet? How about now?" It's exhausting. WebSockets just open a single persistent TCP connection. It's almost like a telepathic link.
Both the client and the server can push messages instantly in full duplex mode. By cutting out all that overhead of constantly reconnecting, you get the ultra-low latency you absolutely need for live dashboards, gaming, and real-time chat.
Section 5. Asynchronous messaging and pub sub.
Okay, let's completely leave the synchronous wait-for-an-answer world behind. We're talking about the radio broadcast model now, the publish-subscribe or pub-sub pattern. Say a user uploads a photo. The publisher just produces that event and drops it into a middleman called a message broker. The publisher has no idea who's listening, and honestly, it doesn't care. The subscribers, like your notification service or the feed algorithm, they tune into that broker. The second the photo drops, they react. This asynchronous fire-and-forget communication completely decouples your microservices. So if your notification service crashes, guess what? The photo upload service keeps right on working.
To actually pull this off, we use what I like to call async messaging warehouses. And the scale here is just staggering. Apache Kafka can process literally millions of messages per second. It is perfect for massive event streaming. Then you have RabbitMQ, which is fantastic for complex routing of thousands of messages. Or Amazon SQS for simple managed cloud queuing. When your app suddenly goes viral and traffic spikes 10,000%, these message brokers act like giant shock absorbers. They buffer all that noise so your backend services can just process the work at their own safe, steady pace.
Now look at this survey data from the YPEC journal. It shows exactly how this stuff plays out in the real world. You can see 44% of IT practitioners are actively using complex transactional messaging to manage these async flows. And zooming in a bit, domain events are hugely popular, used by 59% of respondents. It just goes to show that maintaining data consistency across all these completely decoupled asynchronous services is a massive priority for modern systems.
Section 6. Choosing your communication protocol.
All right, so with this whole API multiverse laid out, how do you actually pick the right one? Well, this matrix distills everything we've talked about into one simple guide. If you're building public APIs, stick to the reliable REST postal service. Building a mobile app where clients need super flexible queries, summon the GraphQL query mage. For blistering fast internal microservices, you want the gRPC FedEx courier. If you need live bidirectional action like a chat room, use WebSocket OWL messengers. And finally, for background processing and surviving massive traffic spikes, broadcast your tasks through asynchronous message queues. At the end of the day, the protocols you choose are so much more than just technical details. They dictate the speed, the resilience, and the core user experience of your application. Using a slow postal service during a real-time emergency, or shouting a private internal command over a public radio broadcast, it's a recipe for failure. In the multiverse of APIs, communication isn't just about moving data. It's about choosing the right medium for your message. So, as you architect your next major system, ask yourself, are you building an environment that speaks the right language, or is your data getting lost in translation? Thanks for joining me on this explainer, and I'll catch you next time.